Alright, ladies and gentlemen, so today we're moving on to the second lesson where we're going to talk about what do we do if we multiply numbers in scientific notation. And we have a formal example up here, but I just want to show you guys something. So if I have, for example, 2 to the third times 2 to the fifth. That's my example. Well, we know from yesterday that 2 to the third means I'm multiplying 2 by itself 3 times. And 2 to the fifth means that I'm doing it 5 times. So if I want to put these two things together, multiply them together, how many 2's am I multiplying? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 8th. So what I'm looking for is a shortcut way. What is my shortcut way of being able to go from here, the starting, to the ending without having to write that out? Well, that's where we're going to come in. So notice my base stayed the same. So my steps, keep the base. If the bases are not the same, it doesn't work. You can't do this. Next thing that we're going to do is we're going to add the exponents. And then we're just going to rewrite it as one problem. Alright, so let's see if we can try it. So for number 1, I notice that my exponents are the same, or my bases, sorry, are the same, both 14. So it says keep the base, 14, add the exponent. So I'm adding 12 plus 8, which is 20. Done. Number 2, base is the same. Because it's a negative base, we talked about this yesterday, it has to go in parentheses, negative 72. Add your exponents. 10 plus 13 gives me 23. Even if my base is a variable, this still works. So I'm going to keep the A. I'm going to add 23 plus 8, which is 31, 8 to the 31st. For number 4, keep my base, F. Add 10 and 13, 23rd. Even if I have a lot that I'm multiplying together, right? Here I have 9, 9, 9. As long as they're all the same, this works. Keep the 9. Then we're going to add, we have to add 9 plus 4 plus 6 plus 8, which is going to give me 18. Down here, we're going to keep our 2's. I'm going to add 3 and 5 and 7 and 9. Doesn't matter which way I add them. So we have 8 plus 7 is 25. No, how about that? 8 plus 7 is 15. Plus 9 is 24. Oh, that sounds right. Let x be a positive integer. I want to know what has to go up here so that I have a total of 14 negative 3's is really what that's asking. So in this case, x would have to be, well, to get from 9 to 14, we would have to add 5. Okay. Can the following expressions be simplified? If so, write an equivalent one. So sometimes now we're going to find the ones that have matching bases. So I can put together the 6's, which is 6 to the 19th, and I can put together the 4's, which is going to be 4 to the 12th. They're being multiplied, so they would be staying multiplied. I cannot put those two things together because this is a 6, this is a 4, not the same bases. All right, let's try another one. So here I have the 15's. If I don't see an exponent, it's always a 1. So this is going to be 15 to the third. Then I'm going to have my 7's times 7 to the 6th. Number 10 cannot be simplified. I have a 5 and a 2, those do not match. Over here, this is 2 to the 4th, and then I have 8 to the 2nd. Well, we know from the lesson yesterday that 8 is really 2 to the 3rd, so I'm going to write this all out. This is going to be 2 times 2 times 2 times 2. This is 8 times 8. But I know from yesterday that the 8's can really be written as 2 times 2 times 2. 2 times 2 times 2. It's almost like doing prime factors. So now, if I count up all the 2's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I would get 2 to the 10. That one was a little bit more challenging. Same idea down here. I know that 9 can be written as 3 times 3. So if I have 7 3's here and 2 more, 7, 8, 9, 3 to the 9th. All right, let's try the next page. Simplify each of the following expressions. Okay, well, they're multiplying. The first thing we do is we're going to multiply the numbers out front. Those are coefficients, they're whole numbers. So I'm going to multiply 2 times 17, which is going to give me 34. Then, for my bases, I have to add the exponents. So x is going to stay, 3 plus 7 is 10. All right, so let's write that down. So you multiply coefficients, oops, sorry about that, and then you add exponents. All right, so let's try this next one. So I'm going to multiply the negative 3 and 4, negative 12. I'm going to keep my base. I'm going to add the exponents. 2 plus 5 is 7. For number 15, I'm going to multiply the coefficients. Negative 2 times negative 8 is 16. I'm going to add, there's a little 1 there, I'm going to add my exponents. M to the 6. Number 16, we're going to multiply 3 times 2, negative 3 times 2, negative 6. Now with this one, I'm going to match up my h's, right? I have h squared, h to the first. I'm going to add those, h to the third. Then I'm going to do my g's. I have g to the first, g to the fourth. Keep the base, add the exponents. All right, next one. Multiply the numbers out front. Negative 11 times negative 5 is 55. Then I'm going to have my w's. W to the fourth, W to the third. Add those exponents, that's to the 7th. I don't have any other x's, so I just keep x to the fourth. Okay? All right, distributive property is when we take what's on the outside and we multiply it by everything on the inside. Well, if I do a times a, those bases are the same. You're going to add the exponents, a squared. A times b, different bases, so those are just going to stay ab. Over here, same idea. B times a, different bases, we're just going to multiply. B times b, same base, add the exponents, b squared. Okay, so this is definitely new. It's going to take some getting used to, but I have every confidence you guys are going to be able to do this. So any questions? Bring them to class. Have a good night.